एनसीईआरटी का 11th का जो चैप्टर नंबर 3 है उसका क्वेश्चन है. So suggest a suitable physical situation for each of the following graph. So first we need to know that which situation is responsible and which graph is represent and what is the slope of the graph and what it will represent. So first we need to understand the concept of position time graph. If position time graph is given to us, I will make it some position over here to explain all the things. So first I will explain which graph is representing which situation. So first we should know about the position time graph. So I am just writing the position. So if position time graph is given to us, so what it will represent. So slope of the position time graph position is x and time is t. So the slope of position time graph gives us the velocity. So this must you should remember, the velocity is nothing but it is a slope of position time graph. So if I say, let's take some example to understand the situation. Suppose the slope is a straight line like this way, and this is the position of the particle and this is the time. Then we can say this straight line, the slope is nothing but it is a tan theta. This is called the slope of the straight line, and it is generally represented by m. So if theta is constant, then we can say tan theta value is also constant. If it is constant, then we can say the slope is constant, and slope is nothing but it will represent the velocity. So we can say velocity is constant. So velocity is nothing but it is a vector quantity, and we know any vector quantity will have one direction as well as with magnitude. And this magnitude contains unit and a number. Okay, let me take one example. Suppose I say that it is 4 kg. So 4 kg means it is representing the mass. So if 4 is a number and kg is the unit, so this is the number and this is the kg. So this is nothing but it is a magnitude. Suppose I am writing 4 meter. So 4 is a number and this is nothing but it is a unit. This is unit and this is a number, any real number. So this will represent the magnitude. But if I say 4 meter north, so what does it mean? It will represent a vector quantity because it is having direction also, and this is combined with magnitude. can say 4 meter north, it will represent displacement, and this will represent distance. Okay, so any vector quantity will have direction plus magnitude. So it will have some magnitude and it will have some direction. So this thing, I think you're getting what I'm saying. So now this is about the position time graph, and the slope of this position time graph is represent the velocity. So this is a whole about the position time graph situation. Now come to the next point. If we have a situation, suppose we have a velocity time. So what does it represent? So if I have a graph in which one axis will represent velocity and other axis represents time. So graph is, maybe I am taking just example of straight line to understand what does it represent. So if the velocity time graph is this, so this is straight line, and we know the slope of the straight line is constant. So we can say the slope of velocity time graph represents basically acceleration. So in this case, slope is constant, so we can say acceleration is also constant. If we have graph like this way, so in this case we can say, because it is making angle 0, so we can say in this situation acceleration is also 0. We can say velocity is constant. But in this situation velocity is not constant, velocity is continuously increasing. Okay, so in this case we can say also the particle is accelerating. Okay, so this is about the velocity time graph. Now we are going to solve these three situations. What are the physical situations are given in graph A, B and C. So we are going to relate the situations. So first let me remove this thing. So this is all about the fundamental of velocity as well as see the first situation. So I'm just now you can see over here. This is the slope, this is the position time graph, and we can say this is the slope. And in this case, the slope is positive because this angle is theta. So we can say this time is particular time. Suppose I am taking this time is -2 seconds. So from -2 seconds to 0, the particle will have, because in this situation the particle or any object will have a constant velocity. But the slope is positive because if you will see, I'm just because this graph is like this way. So in this case you will see this is the time t is equal to -2 seconds. I'm taking this example, for example, and this slope is positive, and we can say in this section the velocity is constant plus velocity is positive. So positive means, suppose I am taking any direction positive. Suppose a object is moving, this is the object and this is time t is equal to 0, and this is the time t is equal to -2 seconds, and it is moving towards the positive x-axis with a constant velocity. Suppose this will have some velocity. I am taking just take for example 2 meters per second in this positive direction. So this direction is nothing but it is a I cap. So when time t is equal to 0, when this object comes over here, then the graph is like this. It means at this moment the direction of velocity will change. Why? Because now you will see this angle phi. This angle phi is greater than 90 degree, but it is less than 180 degree. So the value of tan phi for angle which is greater than 90 and less than 180, then it will be negative, and this is nothing but it is a slope, and slope is nothing but it will represent the velocity. So now the direction of the velocity will change, and I am just assuming that this angle is, the slope is same. Same means this will have some velocity in this direction at time t is equal to 0. So it will change its direction. Now again you will see it will move, because at this time t is equal to t minus 2 second, its position is x is equal to 0, but at time t is equal to 0 second, its position becomes some x is equal to, suppose I am taking this as 4 meter, for example 4 meter. Now again it will change its direction of motion. So these slopes are, I am just assuming this will have some velocity v1, okay, and this will move and it will cross, because at time t is equal to, this time is, suppose I am taking t0. So at time t is equal to t0, again this ball will reach over here again, this point at time t is equal to 0. So I am just putting over here the situation. So this is at time t is equal to t0, and again this will have some velocity v. So this time t0 is positive. So then again you will see this time is, suppose t1, up to t1. So t1, this is the time, and now this ball will at time t is equal to 0, sorry, time t is equal to t1, this ball will have this position. So this position I am representing, because this is the negative position. So this is the negative x0 position. So this is the negative x0 position. Now this is the final situation. So we can say at this moment the ball will stop. Why? Because after that, if you will see, the slope is 0. So this is the time t is equal to t1. At this position, this is minus x0. So at this moment the ball will stop. So ball stops over here. So it is at rest. Now this is the physical situation which will represent this graph A. Initially the ball will move towards right, then again it will move towards left, and it will move towards left extreme up to the negative x-axis. So maybe there is a ball, so there is a completely inelastic collision, so that's why this ball will stop over here and it will start from this point. So this is the whole about this graph. Now I am going to discuss the second graph. So second graph is like this way. So first I need to clear this. Situation what is given to us, there are lines like this way. This is a straight line. Straight lines are like this way. straight line is constant. So you will see over here, this is the time just like this way. Just like this way. Now you will see the velocity magnitude is continuously decreasing. Magnitude of velocity is continuously decreasing. It means what? It means this is the velocity and time graph, and velocity time graph is nothing but the slope of velocity time graph. Now again you will see this angle is theta. This theta is greater than 90 and less than this is 180. Okay, so now the value of tan theta will be negative. So just assume that, because at this point the velocity is positive, so we can say, and this velocity is highest, so you just assume the velocity is highest. So if I throw a ball towards upward with some velocity, and this is highest velocity V0 I am taking. Okay, so this upward direction is I am taking, this is positive direction, and this will go up. At this moment this velocity will go down because velocity is continuously decreasing. So this is the negative time. Suppose this time is minus T0. So this time is minus T0 time. At this time is time t is equal to 0, at which the velocity becomes 0. Why this is so? Because slope of the velocity time graph I have showed to you that it will represent nothing but it is the acceleration. Now you will see this is a straight line. This is a straight line. So straight line slope is constant. What does it mean? It means the acceleration is also constant, but acceleration is negative in direction. So we can say if I take upward direction is positive, then automatically the g is acting downward and the value of g is fixed. This is 9.8 meter per second square. So we can say the slope is negative. Now here the acceleration is also negative. Why this is so negative? Because this direction will be negative and it is constant, its value is fixed. So slope of each straight line is constant. And why? Every time, because when it is go down, the direction of velocity will change. Now the direction after the time t is equal to, because this is the time t is equal to 0, after crossing this the velocity will be negative. Earlier the velocity will be positive, so it will go down, again hit at this ground, again bounce back, but now it will not reach up to same height. So it means there is some rebound velocity V0. So this is V0, V1 is value of this rebounding velocity is in magnitude wise, it is less than the V0. So that's why each and every rebound, the velocity continuously decreases, and after some time you will see the velocity becomes zero. So this will show the velocity becomes zero after certain time. So this is the actual real situation related to this graph, real physical situation. Now I am going to discuss the last graph which is given to us. Last graph is given like this way. This is the acceleration time graph, and this is like this way. A sharp peak is there, and then again it is comes to zero. And this is nothing but it is the acceleration time graph. So it means in the very short time interval, suppose this time interval is T0. In very short time interval, the object will have some acceleration, and again this acceleration goes to zero. It means this situation is representing to a impulsive force, acted on the object. What does it mean? It means suppose a ball is there, and if I hit this ball with a stick, okay, with a stick, this is the stick. So earlier the velocity, because this ball was at rest, now if I hit this ball, so for the very short time interval, when the stick is in touch with this ball, then it will accelerate and it will have some velocity, it will achieve some velocity, and it will go like this way. It means we are applying the impulsive force over here. This is the real physical situation we can relate. So if a ball is hit by an object or a stick, okay, then there is an impulsive force imparted on the object. So that's why this ball will have some, in a very short time period, it will achieve some velocity v with the help of this impulsive force. So during that time interval it will have some, because during the time of the force, this ball will have some acceleration, and this acceleration is very large. Okay, so this is the real definition of the impulsive force. If a very large force acted for a very short time period, then it will change in the momentum of the object. Okay, so this is the real situation. Thank you. So please share, like and subscribe for this channel for more questions. I will explain each and every questions of NCERT, and further we take HC Verma, and that will also help you to sort out such kind of problems, and such problems solutions are not given in NCERT. So it will be very helpful. So thank you.